let's solve this LeetCode problem. It's called product of array except self, and there's an array. This is given, and we have to return a new array where each of the value is the multiplication of all the values except that one single value. And it has been guaranteed that the total multiplication will be within an integer 32-bit integer range. So it will not cause a memory overflow, which is great. And we need to find an algorithm that runs in order of n time. And we cannot use division. So the easiest way would be to just go through all the values and just multiply them and divide each value. But here we cannot actually do that. So just take for this example, 1, 2, 3, 4. There are 5 values in this array. And in this one, we have to find if it is a division was allowed, we could actually multiply all of them together, and that multiplication would be um, to multi it'll be 120, and it was divided by 5, and 120 divided by 1, 120 divided by 2, 120 divided by 3, 120 divided by 4. But we cannot use division operator at all. So instead, what you need to do is we need to find a clever way. How can you get the multiplication of all the value except self? So to do that, we have to consider this example 5, 1, 2, 3, 4, and for this first value, the multiplication would be 1 times 2 times 3 times 4. And for the second value, the multiplication would be 5 times 2 times 3 times 4. So you can find a pattern here, and for this one, it has to multiply this 5 and then 1, then it has to skip 2 and then go to 3 and multiply 4, right? And for the third, it's the same thing, 5 times 1 times 2 times 3, and finally for the last value, it will be 5 times 1 times 2 times 3, right? Oh, sorry, I made a mistake. For the third one, it will not multiply 2, rather it will multiply with 4. So this will be the total value. So for the first one, the summation was 20, the multiple is 24, and the second value, this is the total is 120, and the third number 2 is uh, 60, and then the third value is 40, and the fourth one is 30. So this is the array we need to return. But you notice for this one, if we go to each value at a time and multiply and rerun the for loop one by one, that would be a total runtime of order of n squared, because you have to just go through each value once, and again we'll have to just rerun the same operation for each multiplication. But instead, if you just notice, we can actually do it in a much more clever way. uh, that'll help us reduce the runtime to order of n, and we would be able to space runtime complexity will be order of 1, because we can actually just reuse this return array itself to the computation. To do that, what we can do is we can, for this first value, we can have a 2 pass and just erase these values. Uh, and in this 2 pass, we can, first of all, we can see for each number, we have to just see all the previous values and all the values following it. So for 5, all the previous value is nothing. There is none here. So we have to assume there's 1. So there's 1. And for 1, all the previous values needs to be uh, for this one we have to just install or we have to just multiply all the values together. So we already know 1 is here and there is 5, so the total previous is 5. And for 2 we know that the previous values multiply into 5, so it will basically be 5 times 1 is 1, this value comes here. And then for 3, what are all the values except this one? So 1 times 2 is now 2, and then for 4, sorry, 1, I'm sorry, this is 5. For 2, it's just multiplying 5 and 1, so it's 5, and the one before is a 5. And for the 3, this is actually going to be 10 because we are multiplying 5 with 2, and this is going to be 10. And for 4, this 10 is multiplied by 3, so this is 30. So this is the forward pass of the algorithm, and the backward pass, we have to just find all the values after this. So for after 4, there is nothing actually. You have to assume there's 1. So we have to multiply this by 1, so the total is actually 30. For this value, number 3, now we can use a different color maybe. So the all the values is 1 times 4, so we have 4 times 1, this is actually 4, and if you multiply with the prefixes it is 40. Now for 2, if we again 4 times 1 times 3, all the values after this current one, so we already know this is 4, so it's equal to 12. 12 times 5 is 60, so we get the answer. So you can actually go backwards like this. And for this one value, uh, for 5, we know that we already had 12 and have to multiply it by 2, so this is 24. And 24 times 5 is 120. And finally, for 5, we know that all the values are 24 and 1 is 24, and if you multiply these two numbers, 24. So you can actually just use one single array. We just go move forward and come backwards, and that way we can actually solve this one very easily. So let's solve this one. So we have to, should be a very easy problem. I equals, we have to start from 1, and before we are just running some prefixes first. And for prefixes, we know the first one that we have to assume the multiplication is just 1, right? And this way, I is going to be I minus 1 uh, times I minus 2. So we are just multiplying the previous two values. So just as you have seen in the example, so for this one, this is 1, and for 5, when it's 1, so after we reach the first value, this is going to be the previous one, uh, along with this value is currently with the previous value, and the result. Okay, so we are basically at the result. It is basically the numbers I minus 1, and that is going to give you this array. So you just take the previous value and multiply with the result. So our results are here, here in this array, and this is nums, and this is the results. We have two arrays, right? So the result is this one. So this gives you the forward pass for the prefixes, and we're coming back. And 0 and I minus minus. So this time we're actually going backwards. And for backwards, we're going to just use, uh, so for backwards, uh, we know that we have the following values are 1, and for the last value, as soon as you get the value, all the multiplication is done. So we have to start with 3, which is the very second last, and for 3, we're going to get the previous value from the uh, numbers array, and you have to multiply it whatever is there in the result array. Result I times numbers I plus 1. So this way, I plus 1 is 4, but if from numbers, but the current result is just that I position is 3 is 10, and we'll just multiply with 4. It will be 40. And then when it comes to 2, we will know that the previous, uh, the current value is 5 here, and we're multiplying that with basically 5 times, we have to multiply with 12. So we have to carry over a value. Uh, might have to just create a new variable here. So we're carrying something over, and here the carry was essentially 1 for at first, and when you're at 3, we have to for each one carry times 4. So we have to use numbers I plus 1. So with this logic, numbers I plus 1 at first carries was 1, and now, and when it comes to 3, the carry is now 4. So multiplying with 4, and when it comes to and 4 times 10 is 40. That's the value we are storing right here. And then when it comes to 2, the carry value is now was 4 previously. Now the carry is 3 times 4 is 12, and that's what we're multiplying with, and that will just return us the answer. So that's what we need to return. So let's run this first and see if it passes. Uh, there is an error there, so we just fix this. Oh, we made this mistake. It should be 2. Yep, it passed. Yeah, it actually passed. Great. And the total runtime complexity for this one is order of n, and there's no extra space needed, so it's order of 1 space complexity. Thank you for watching.